Hello everyone. Welcome to the solution of LeetCode problem 895 named maximum frequency stack. In this problem, we have to design a stack-like data structure to push element to the stack and pop the most frequent element from the stack. Here, we have to implement the frequency stack class. At first, we have to construct the empty frequency stack. Then we have to implement two methods, which is push and pop. Now push will take a value as a parameter and pushes an integer value into the top of the stack. And pop removes and returns the most frequent element on the stack. And if there is a tie for the most frequent element, the element closest to the stack's top is removed and returned. That means if multiple element has the same frequency, in those cases, the element which is the closest to the stack's top position should be removed and returned. Now, if we consider the first example, here we can say that for an empty stack, if we push the element 5, the stack is 5. Then if we push the element 7, the stack is 5 and 7. Then if we push the element 5 again, the stack is 5, 7 and 5. Again, if we push the element 7, 4 and 5, the stack will become 5, 7, 5, 7, 4, 5. Now, if we pop the element, at first we have to check which element has the maximum frequency and it is the closest to the top. Here you can see that the element 5 has the frequency 3, 1 here, 2 and 3. So here we have to return 5. So if we return the 5, the stack will become this 5, 7, 5, 7, 4, which is this. Now if we again remove one element by using the pop function, we have to return 7 because here in this stack, the element 7 appears 2 times and element 5 appear 2 times. So there is a tie, but we have to remove the element which is closest to the stack top positions. So here 7 is closest to the stack top position 4. So here we have to remove element 7. So now our stack will become 5, 7, 5 and 4. Again, if we apply the pop method, we have to return the element 5 because in this stack, the element 5 appears 2 times. So we have to return it. So the stack become 5, 7 and 4. Now, if we again use the pop method, we can see that the element 5, 7 and 4, all of them has the frequency 1 because they appear 1 times in the stack. So here we have to remove the closest element to the top. So here the closest element to the top is 4. So in this case, we have to return 4. Now the stack becomes 5 and 7. I hope you understood the problem statement as well as the examples. Now here the constraint are, the value can be in between 0 to 10 to the power 4 and at most 2 into 10 to the power 4 calls will be made to push and pop. And it is guaranteed that there will be at least one element in the stack before calling pop. Now I hope you understood the problem statement. Now let's move on to the algorithm. Now we have to make one stack and perform the push and pop operations. And we have to remove the most frequent element by using the pop operations. So we have to make a stack-like data structure, but wait. We can make a stack. We know the property of the stack is last in, first out, because the element which appears in the stack at last should be removed from the stack at first. But again, we can implement a stack by using the priority queue here. So the algorithm is pretty simple. We have to make a priority queue, but each entry of the priority queue will have 3 values. Now, let's understand the algorithm very carefully. The first entry of the priority queue will be the frequency of the given element, which is F. The second entry of the priority queue will be the position of each element, which is P. and the third entry of the priority queue will be the value itself. Now, for each of the element in the input array, we have to insert these 3 of the value. Now, we have to implement 2 of the method, push and pop. For the push method, we can simply insert this pair of values into the priority queue. But for the pop method, we have to remove the most frequent element. And if multiple element has the same frequency, then we have to remove the element which is closest to the top. So let's see how this combination of value will satisfy the given constraint. So as we all know that for the priority queue, if we use the max if, the maximum element will be stored at the first position or the top positions. So for the max if, the combination will, suppose the combination will be 5, 4, 3, 1 and so on. Here the value will remove from these positions. So for the max if, the maximum element will be removed from the heap at first. After that, it will remove the minimum elements. So we know that in the priority queue, the element is sorted at first using the first value, which is the frequency. If both of the value have the same frequency, then the element will be sorted by using the positional value P. But as for each of the element, the positional value is different, because suppose for this element, the positional value is 1. For this element, the positional value is 2, and so on. So as for every element, the positional value is different. So if we store each of the element using these 3 values, then if we apply the pop method, we can simply get the most frequent element, because in the priority queue, the at first element will be sorted using this first attribute f, which is the frequency. That means the element which has the maximum frequency will be removed at first. And if multiple element has the same frequency, the element will be sorted by using the positional value. But as each of the element has different positional value, that means if any element has the maximum positional value, it will be removed at first, because the more the positional value, the more it is closest to the top position. And at last, we have to insert the corresponding value itself. And if we remove one of the pair from here, we have to decrease the frequency. And to track the frequency, we can use simply the C++ map mechanism. So to solve this problem, we can simply use the map and the priority queue. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a class name frequency stack. Here we are initializing a variable pos to 0. Now here we are using a priority queue and a map. Now to push the element into the priority queue, we are simply increasing the frequency of corresponding value in the map, and we are making pair of the corresponding positions and the value. That means 3 value is stored for per element into the priority queue. Now for the pop method, we have to simply take the top element from the priority queue and remove it. And we have to decrement the frequency of the corresponding element in the map. Finally, we have to return the last element from the map. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.